Hello, everyone. Thanks for joining us today. Good evening, good afternoon, good morning from wherever part of the world you're joining in. Thanks for joining, and we really hope you all are doing well. And we are really praying for normalcy in Ukraine as soon as possible. And with that, we welcome you all to the 14th Data Catch Up session by Kaggle Days Meetup Delhi NCR. Today we have Wagner. He's a data scientist and DPO at Datarisk. And today he would be helping us with a session around demand forecasting using time series. Like this session is really interesting, keeping in mind the importance of demand forecasting in these tough times and how much it's useful for the industry as such. So I hope this session would be useful, and you could ask all your questions in the chat window. And we also have a few questions from the community members who would not be able to join due to time zone differences, but we would be taking up those questions towards the end of the session. Thank you, and over to you, Wagner.
Thanks, Vero. First of all, I'm solidarity for the Ukraine people. I pray for you guys. I know that it's tough days, but I know that everything will be good in the end, I hope. So, good morning for those who are in the sunny side of the world, and of course, for those that are in the dark side of the world, not the dark and one, but the evening. Good evening for the other side, like in India. I guess that's night. Yeah.
Yes.
Well, I'm happy and glad to be here sharing knowledge to our community. So I got COVID a month ago. Then I apologize in advance for the coffee. Okay. First of all, I'm Wagner, master in economics. I'm data science. I'm also a DPO, and I'm doing my PhD student. I'm a PhD student, my doctorate degree in software engineering. Then, as data science at Datarisk, I use artificial intelligence just to building models and provide companies use data to their advantage. As data science there on Datarisk, my main role is building tailor-made demand forecasting solutions, time series forecasting is statistical, so machine learning and deep learning models help companies to predict sales or forecasting sales. In other front, we in Datarisk, we also doing other solutions, just as classification problems, custom segmentation, credit score, behavioral models, and whatever. And also as a DPO, data protection officer, I'm responsible for protection and privacy of personal data, ensure the rational and unbiased use of data to feed our models in Datarisk, and of course, making the policies to be adhere to general data protections law. Of course, I'm also a lawyer, and then that's why I'm also wearing the cap of DPO there. Let's show you, and let's rock. Let's start our presentation here. Now we are talking about demand forecasting. And of course, demand forecasting is a subject related to time series. And the first thing that everyone thinks about demand forecasting is why it's so high or so troublesome to predict sales. But before that, let's just intro everyone to the same place, stay in the same ground. First of all, what's time series? It's a series that stays in the time, of course. But I have a good explanation that I took from Ben Offord in his book about time series in forecasted sales. That's a set of data organized in chronological order. The data has only is only available, has value only in a specific time, monthly, weekly, yearly. We can't just mess up the data or put it randomness. It only has value in a order, in a chronological order. And why forecast? Previsibility. But previsibility is too vague. Sorry. It's why we need previsibility, so you can just look at the sky and see if it's going to rain or not. Just trying to forecast the weather. But the important thing is what you are going to do with that information. Just for instance, think in retail, a retail market, just Walmart, just for instance. There they have a perishable goods and non-perishable goods. Perishable goods is a good that has a expiration date, a short expiration date. I mean, just like fresh meat, fish, or other kind of food, like milk derivatives, for instance. And non-perishable are products that you can stock, you can have in your inventory for a long time. Then it's really important to predict and to have a previsibility of your sales, to know how you compose or you do in a mix in your market. Just for instance, and why is sales forecast so hard to predict? Well, first thing is because we don't have all data. Just thinking about it. Well, if I flip a coin, of course, it's a classical question. If I flip a coin, I have a half percentage, a half probability, a likelihood to have one side or another side. But what if I tell you the exact position of the coin to be in my finger, the strength that I use? If you could measure the higher, how high the coin will do, the numbers of flips, do you think that we also have the same probability 50-50 with all those informations? I think that we will get higher probability from one side or the other. The same is the sales forecast. Just for instance, if you know that products are going to be a discount, you are going to have a discount in the future, so it's information that will change your sales. Or even if you'd like to, if your product is based on dollar price, so if you could see or could know the value of dollar in advance in the future, of course, you could predict also your demand or your costs. So you don't have all data. That's the first thing that makes our sales forecast hard to predict. Second one is extrapolation. To predict something for us data scientists, too easy. Fit and predict. It's easy for us, but what if we would like to predict a few steps ahead? Just walking in the timeline to the future. I would like to predict 3 months ahead, or 4 or 10 months ahead. How could we do it? Fit and predict. If we just fit and predict, we have that situation here. And what that situation means that I have a series here. Let's just put a later. I have a series here, 7 observations, and I'd like to predict the 8th element. So fit here and predict here. It's easy peasy. But what if you'd like to predict the 9th or the 10th element? Fit predict would not help us. Then we have to make a strategy to walk in the future. even use fit and predict. We call it that strategy, the most used one, a recursive one, because I have to predict the 8th element, feed it to the model as if it time right now, to try to predict the 9th and 10th element, just as we're doing here. That 8th element here is our last prediction. So just think it. So you are in February, okay? Just imagine. So February is the number 7 here. We are here. We predicted March. Good. Then we have to pass that prediction to the model. Then the model will be 0 to 7 plus March prediction to make us, or to available us to predict 9th element, that's April. And we are walking on the time here. If you'd like to predict May, we have first to predict March and April and pass that predictions to the model, feed them to the model. Then our model has 7 elements, or 8 elements going to 0. 8 elements here, because you are using here a 0, 1. 8 elements, real value, that's exactly our real value, plus 2 predictions here. But of course, all predictions has errors. Then you're feeding our model with errors to predict the 10th element. Then, using that strategy here, you could predict 3 months ahead, if of course you are dealing with a monthly period. But that's why predicting future is a little bit hard, because the error in the past predictions are feeding the model. And of course, further we walk in the future, more error are feeding our models. So I have a GIF here that I take it from SQ Forecast library. An amazing library that I will talk about it later. It helps us a lot. We are here in that exactly point. Just help us to understand it better. So now we are here in that line, and then to predict the other points, and we have to walk. First predict this one, then after predict that one, then after predict one more. It's one step ahead, and of course, when we predict that one here, we will feed our model to every observation behind it. That error will contribute to the future's predictions. So we are doing error propagation. One error contributing to the next error, into the next prediction, into the next prediction. So I think that's the hard part of predicting sales. It's the extrapolation one. Not only this, we have another complexity that's we're dealing with endogenous variables or exogenous variables. We have those kind of information. And endogenous variables is the only the series. If you're talking about sales, we can look at only our sales in the past. It's an autoregressive model. Just looking at the past for the past sales and try to predict the future sales. So in that case, we are only using historical sales. We are reducing the complexity of the prediction. Good. And we are doing an univariate time series problem of modeling or dealing with this. How does it work? Again, I take it from SQ Forecast library. That's amazing, and I will show you them. I will show it to you. Guys. So it's exactly the same thing that I showed before. We are just looking at the on series and try to predict that red ones. Easy, easy. The problem is when we feed our model to exogenous variables, we are adding extra variables to our model, then the complexity are going to increase a lot. We are dealing with multivariate time series. Then, what's the problem now? We have exactly what we showed before. Okay, we are in time. We'd like to predict time 6, 7, 8, 9, and 10. So when we are using external information, we need to know a future extra information. Of course, you have to train our models using the past external information, but when we are going to predict it or why, we have to know our future, the future of those external variables. Just imagine, I would like to predict the sixth element. Sixth element here. Great. I feed the model to 1 to 5. We already know those variables. We already know those values, but we have to add an external information. F. F is contemporaneous to the or target. What I'm trying to say here is F is a future information. If you are in February and would like to predict sales in March, and we are using an external information like exogenous variables like that product, that kind of product will be on promotion or not on next month. Then you have to put it here on next month will be promotion. Good. You can pass it to the model. No, we won't have promotion for that product. Are going to be a discount or the price are going to be increased. Then we have to pass that information. But that information is in the time of our I, Y variable. Then that's our complexity here, because when we are dealing with variables that we already know, great. But what if we were talking about dollar or other variables that it's hard to predict or we didn't know in advance? That's what I'm bringing here. We have past information filter, past information about exogenous variables, and future info. So past and future, we have future that we know in advance. A product are going to have a discount or on promotion or whatever. That's information that now we know that will happen in advance. That helps us a lot. But there is some kind of information that we don't know. We talked about dollar. Great. Is it easy to predict dollar on next month? In the next 3 months? In the next 4 months? Our currency here is real. I'm Brazilian. Okay, so my currency is real when there is a high volatility or variability between real and dollar. Sometimes in a month we can have 10% of variability between currencies. Then it can be a good predictor, a good feature, but it's hard to predict in the future. And sometimes when you try to use it in your model, to feed your model with that kind of information, it produces a lot of noise. You know that's a good feature. You know that is a feature that tells you a lot about your sales or your future sales or present sales, but it's hard to predict that variables in the future to pass it to your model. When you do it, sometimes your model lose performance. Then you have vanilla tasks, that things that you know in advance about your model. Then hero tasks that predict things that is difficult to predict. And we have a few ways to do it. We have now statistical models. That's models easy to use, just like Riemann, Holt winters, and etc. So you just have to do fit and predict. No, not predict. Dot forecast. They're using another form, another way to do the forecast. But all of those models are doing it is exactly that under the hook. Rima is a good model. Sarima using seasonality and also can use external information, exogenous variables, Holt winters, exponential smooth, triple move average. So you can use of those methods. You can also transform the problem, that's a forecast problem, in a supervised problem. Then you can use regression. And to use regression, you have to reduce the data set to use it. But it's easy. That's our focus right now. Okay. Statistical models are very easy to implement it. You can just Google it, and it's be very easy to see a tons of tutorial to do it. But regression problem, when you are dealing with supervised models, for time series is a little bit tricky. So that's a series, and a regression problem is just like this. We have 2, 4, 8, 16, and which number will be the next? Easy busy. The problem is we are in time t. We're looking at the past, time t minus 1. Just thinking about monthly problem. Last month, t minus 2, 2 months before, t minus 3, 3 months before. Then that's our future, t plus 1. And we have some libraries that can help us to do it. And those libraries I will show to you guys, because dealing with forecast time series doing your own code is a little bit tough. And there's a lot of tricks. And we don't need to know everything, but just for a first introduction or for a first video here, 1 hour is not enough to show all the possibilities of time series or demand forecasting. Then I pick up some libraries that can help us to do it. And now I can guarantee to you, in the end of this video, you can do your own forecast to predict sales or to predict whatever you want, with a few lines of code using ask time, not times. Okay, that is not that last task here, my bad. And ask forecast. In the workflow of both, it's easy. You can do it with 5 lines. First of all, you have to prepare data, set up a horizon to ask time. Set up a horizon is how long steps ahead in the future I would like to walk. 1 month, 2 months, a year, 30 days. You have to choose our hero model. Just pick up someone from supervised. Okay, we are dealing with only supervised here in the first video, in this first video. And you have to pass the number of flags. Number of flags is just that here, you know, this length, the length of your window or your series that you would like to looking back to try predicting the next value. Fit and predict is an easy syntax. skforecast is also a good library that I do strongly recommend. You know, it's even easier than SQTime. You have to prepare data, of course. Now, just prepare data is make it time series. You have to treat the data column. Choose your best heroes, your favorite heroes, your hero model, and pass the number of flags. Fit and predict. Just it. Let's show how it works. So first of all, we are using airline data series that a data set that you want to predict the airline's demand. Exactly what we're doing here. What we are doing here. That's our data set. Have a period column. It's a series. Have period column and the number of passenger. So we took it here at 13. You know, we have a year here and January from the next year. Why are you doing this? To try use it as a regression supervised problem, we have to change it. We have to change for a column to make it a tabular one. You know, from January to December, are going to have our rows and our Y, our target, are going to be this here, just like that. We're going to take the first 12 elements to predict the 13 element here. That's our Y, X, and our Y. So let's just take a look of our data set. So it's not our goal make a time series analysis just to show how we can use supervised models to time series tasks and forecasting tasks doing from an easily way. No, it's not an analysis time series, okay? But you can see here that it's easier to see the seasonalities, here a trend, and you also have a noise, but we're not dealing with those components in this video, okay? Those presentations. Then how can we create our data to be just like that here? So I prepared that code here to show you how we can do it. So the number of flags that it's arbitrary, okay? I choose 12 flags because it's a monthly model. So 12 is a year. It's easier to see some seasonalities or whatever. Then we can also do this in a list comprehension where I'm choosing a for while just to make it more clear. Okay, you are just taking the first window, that's the length of 12, and say the first 12 numbers of the time series are going to be our x, and the 13 number will be our y. And in the end, I'm transforming x and y in NumPy arrays. Easier for us. So that's our y0, x0, and our y0. Exactly the same here. Our x0 and our y0. That is how we prepare our data to feed our model. But we also have another complexity, that's extrapolation. Extrapolation, I have to walk in the end. We have to walk in the time until the end of training, and then predict the next element, feed the next element here in exactly that model here. Just as imagine that we predict that our sorry, we predicted element is that one. So we have to put it here and remove the first one. That's it. But we can do it easier using some libraries that can do it for you. So we don't need to wasting your time doing it. And SQTime is one of them. Very easy to use. We can do it does your temporal split. That's amazing function. That has his own maybe function. Use it. Make reduction is just to transform a series or data frame into a supervised problem. Choose regression problems. And it has also a very convenient building function that is plot series. So you don't need any more to plot or to make your functions to plot. Let's run here. Horizon is our future. How many steps in the future would like to walk? And it's an NumPy array here. I choose my hero model, that's linear regression. Well, why linear regression? Linear regression just to show you that even a naive, not a naive, very simple model can perform well in this kind of tasks. When you're talking about demand forecasting, sales forecasting, a lot of people say, oh, using tree, busting, using whatever, deep learning. But sometimes you have a good accuracy, a good metric using simple models. And that's exactly what I'd like to show you guys here. Windows Lens is thinking about lagging. Is the size of your window that are going to walk in the time. Instantiate a forecast. Use that function, make reduction, pass our model, number of flags, and our strategy. Sorry for coughing. COVID side effect. And also it's allowed us to use a direct forecast. The direct forecast is, the recursive forecast is, I have to predict next month, feed your model to the next month prediction, to try predict 2 steps ahead. And when we use direct forecast, we do not propagate the error. We just create one model for each time period. Sometimes it's a good strategy, sometimes not. You can also use a hybrid model that can use both, but it's an advanced topic that we can talk about it later. So, as you can see here, it's easy. Just fit and predict. Of course, we just split our data set into train and test. So we are just or only using a time series when you have Y train and Y test. And our test size is 12 Y12 monthly data. We'd like to predict a year ahead monthly, of course. You just have to use the forecaster, predict, and pasteurize. Just it. And you're using the map building function, and that's it. Very easy to use. And the library are doing everything or are doing the complex part and the hard part under the hood for you. There is also a convenient function, plot series. It's a good plot. And we did using a simple model. That's a good accuracy. It's a good map when you're thinking about a year. It's not bad at all. And of course, we are just slicing the last 16 observations, but we are seeing the whole data. Again, sorry for coffee. And this library also allows to have a grid search. It has a built-in grid search. Come on, guys. Amazing. You just have to import the class, and that's it. And a sliding window splitter. Sliding window splitter just to have that slide window that we showed before. Now, our X and Y. Our X is composed of 12 observations, and our Y, 1 observation. Sorry again. Then our grid are going to be the Windows length, that's the number of flags. Our strategy is still a recursive one. You just need to pass the model. Then it's going to be a cross-validate. So, which more you would like in time series and forecast? For a first approach, that's amazing. Now, in our company, we have our own framework, but sometimes we rely on SK time and other libraries just to have our first impression about the data, your first impression about the forecast complexity, and also to have a benchmark. Then just we need to pass here a slide window splitter, the initial train window or training part of the dataset that you're going to just train, and after that we're going to walk in our cross-validate methodology or method, and we pass the Windows length of 36. It's a random number, 3 years. You create an object and you just pass a forecasting grid search. Forecaster, that's the object here. Make reduction. A cross-validate method. Slide window, it could be also expanded window that you have not a slide one, a slide walking, but an expanded walking. And that's enough. That's it. That's the object. Window length, forecast, tabular recursive. Okay, we transform the series into tabular. Our estimator and our grid. So that grid, specifically in that grid, I just use a lag grid, but it could pass estimator grid. If it's an extreme gradient boosting, I could pass whatever, all parameters of the model, fit and predict, and that's enough. The return are going to be date, future date, and the predictions. Oh, and our metric was good, 2%. 2% trying to forecast 12 future observation points. It's a good forecast. And we have used a linear regression model, a simple model. We can also have access to the best parameters. And of course, that object here, when you predict, they are using the best parameters. Okay, it store the best parameter. And you can plot our series or our prediction and compare to the real one, our prediction and our test. It's much better than the previous one. I changed the object here. Just to make it fair. So it's a pretty decent forecast. Then you can use that library to help you. It's easy. Has you can transform a complex problem and an easy problem that you can solve or have a forecast or a benchmark in a short period of time. Now we are using the SQ forecast. It's easier than SQ time. Just need to import forecast autoregressive function, grid search. Also a grid search, just like SK forecast. You only think about it to build this kind of or to solve this kind of problem or build a solution for that. You have to build a lot of functions. You have all of them here. Just pass a forecast autoregressive here, the regressor that you'd like to use, the quantity of flags, 15, fit, and predict. That's it. I'll show what the object are going to return for us. Oh, sorry. Flags, window size, if you're using or not exogenous variables, the regressor parameters. That's great. Our prediction, and also has a building function that is too convenient, that get coefficient. When you use that function here, we have the coefficients of each lag. Remember, a lag is a period of time. It's the value in certain past time. Then we can see that the left month contribute in 71%, has a good coefficient. But look at that one here. The 12 lag contributes with 84% to the value, to our value. It means there's a seasonality, of course. You can see here a seasonality, and you can pick up and choose the best legs that you would like to pass to the model. You can also drop some legs here, just pass. According to this, just shows some lags that I would like to test or to feed the model. The metric will be that one. Yeah. Just you can also grid search it. How can you do it? Now we are going to use a random forest, okay? And just to show how it works. So we're going to instantiate here. Shows your hero model. My hero model now is a random forest regressor. Number of flags shows the number that you would like, and that's okay, because we are going to change that flag here using a specific parameter for lags. And of course, our regression parameters, and estimators, and max depth. It's just for fun. Okay, guys. Now our grid result is just to pass the forecast to Y, paragrids, lag grids, steps ahead, prefit to or not, our metric, and also that's it. They're comparing 40 for models. And of course, random forest a little bit lazy model. Good model, great model, but a little bit lazy one. And again, we are using forecast coefficient here. And pass above a different one. We're dealing with 3. Then you can just get feature importance. And it allows us to have the feature importance for few models based forecast. Here, it's returned the number of flags, best parameters, in a backtest metric. The quantity of flags, the parameters, the metric, the number of estimators, and sorted by metric. And you can also test a feature importance. Let's see. You got it, well. Great. And that's it, guys. This is easy framework for time series analysis and time series forecast that you can use. Sorry, as I said, it's a COVID side effect. I'm still coughing. That you can use from now on in an easy way. And the code, almost codeless, I could say. Just 3 or 4 lines, just 4 or 5 lines of code, and you can get your forecast and your prediction. You can do your analysis and use it as your as a benchmarking. That's it, Aaron.
Yeah, thank you, Wagner, for such a useful session, and thanks for taking this invitation up despite your current healing. So thanks for that, and thanks for a really useful session. We have a few questions that are present on the like on the chat. So it's like we will go one by one, and I will pop those questions on the screen.
Okay.
So, like, we had the first question from Kriti. She asks how to account for promotion effects and mechanics in demand models, more along with the lines of separation of organic demand and demand generated via promotions. It's like maybe you are also able to see the comment, right, on the screen?
Yes,
On the
yes.
yes, sure.
Let me just walk through another series, just straight. So I came here. It's Meli. Meli is a Mercado Libre, or Mercado Libre. It's a marketplace, very common here on Brazil, on Latin America, you know. And sometimes it has some competition, some forecast competitions here. And I took a data here, put it here side, and you are just replicate the same methods that we did above to other data set, a real one. Okay, just easy peasy. Pick your data, insert data. We need to set the index to data. Period will be daily one, and just a group by data in sales, and we're taking just beverage. Okay, just to reduce our complexity. That's our data. You can see here that's a yearly common behavior. That's because it's day one of the month. Day one of the month, the stores, almost all stores are closed. It's a vacation, it's a holiday, then it's a daily one. That's our plot. That's the division of our time series. You're dealing with the same thing that we did before, but here you are trying to predict 30 days ahead. Easier? Great. You can see that just 1, 2, 3, 4, 5, 6, 7 lines, and it's okay. Good. And ask your forecast. Same here. It's very easy and convenient to try and to forecast using all kind of series. Now, sorry for interrupt you. Then I will go to the chat to see the question.
Yeah.
So it's a little bit difficult to answer that question. You have to work with the business part or demand planning part in the company. Many of the features that I create as exogenous variables, I have to talk first to the PO, product owner. Sometimes they know that the business owner know all variables. Believe no, they know all variables that can impact in your model, but in the empiric way, they don't know how to use them. That's where and when we goes in, and the best part or the best features that we are working with in real case, we are using the features that the PO pound and indicate for us. Of course, we use others features, like you can pass a moving average, like a feature, just a column, a moving average for month later, or if you're dealing with monthly period date set, 6 months, or moving average from the last 12 observations. But remember, if you have a strong seasonality, if you're dealing with moving average, I don't think so it's a good strategy. That probably could be better if you are trying to use a moving average from a specific period of time, the same specific period of time in the next or the last year or in the last period. If you can see, of course, as seasonality or correlation between periods.
Got it. Got it. So we have another question like what do you do to account for supply side disruptions in a demand specific model? Like we had this COVID lockdowns recently, right? So we had a disruption in the data collection and kind of things. So what do you do to account for supply side disruptions?
Telling the truth, you don't. You can feed the model with some kinds of information, but just to not wrong too much, not do not have just to not have a lot of error, but usually in our case here in production, we have a field that the PO or the businessman that or business management, the demand plan management in the other side can change the forecast. We call this consensus. Then we can contribute to the model manually. But why we pass it? So there's a lot of information that we don't know and we do not fit the model within it. Just for instance, just imagine next week are you going to have a promotion? So I predicted last month, uh, 3 months before, the, the promotion did not into the model. Uh, we do not feed that information to the model, but the men, the guys that are responsible for a demand planning in the company, they know that information. Then we put that space here or that a feature that we can contribute with the model. So just imagine, real case. We know that are going to be a promotion next month. So our model believes that you're going to sell uh, 10 units. So if you're going to have a discount in, you notice you can put add 20%. You know, of
Got
course,
it.
if you know in advance that kind of information, you could fit the model.
Yes,
But
like
real life,
we
it's a little bit tough and tricky.
yes, like that's why the use cases of demand forecasting and the recent innovations in it, demand forecasting keeps going on, right? Like we try to study, we try to come up with certain new advancements that have been there in this, like in this arena or in this domain. So, like, I hope we have discussed this how to include non-time series exogenous. Like, we have discussed this. So, like, we had a few questions from a few of the community members, those who are not able to join currently. So, it's like you discussed about how easy it has become to do time series forecasting just with a little bit of idea around what are we actually doing. So it's like any good resource or any books that you would suggest for them to kickstart their journey in time series, like post watching this video, at least like how they could dive deeper into these things. Or
Yes, there's a good book from Ben Alford. Just take number of the book here, but it's an amazing book. It's a book from last year, and I strongly recommend it. hmm Let me just pick the number of the book and I will pass. But just enter the question that's below. How can we pass exogenous variables to the model? It's not a easy task, but it's useful task. It's not very easy to do it, but you can do it. There's some models that is allowed to use holidays. A bit, it has a built-in functions for holidays. I would just taking just a minute. I'm taking the okay, got it. Just take the book here to share with you guys. It's the book.
yeah,
So
let
okay,
me copy this.
just to talking about the exogenous variables, uh, Facebook Prophet and other models you can feed them with the holidays. There is a specific a specific variable called holidays, you can do it well, and it's easy to handle. For if you are doing a tailor-made one by hand, you have to build your data set, prepare a data set to has, imagine an autoregressive one, 10 legs before, plus another column, that's a column that exogenous variables, another exogenous variables in the column, and the structure are going to be, just imagine, 10 columns about legs, autoregressive model, and the other columns close to the y are going to be your exogenous variables columns. Uh, I would like to work with 0 and 1 in promotions, or you can also use 0, 1, and 2. Why 0, 1, and 2? So if you're increasing the price, you 0 is for regular time, 1 is before or previous increasing price, and 2 for the increasing price. Sometimes you have the behavior that people are going to buy a lot. Depends of the product. Depends of the product that we are talking about. But the people are going to buy in advance, and knowing that that product are going to be increasing price.
Yeah, got it. So thanks for giving us a useful session on this demand forecasting using time series. It's really useful for the community members, and we hope that folks who watch the recording would also find it useful and would reach out to you or via LinkedIn in case they have any further queries. Thanks, Wagner, for accepting our invitation, and we really hope you get the recovery from post-COVID symptoms really soon. Thanks for that, and yeah, it was really a pleasure to host you.
Thanks, Roy.
Thank you.
Would be glad. I'm glad to be here and to share knowledge to our community.
Thank you.